Okay, so we're talking about training the neural network, and we're talking about the hidden layer gradient. But remember that our goal in these recent slides is to find the gradient with respect to a change in theta. So like the derivative with respect to a change in theta, or a derivative with respect to the changes in the weights and also the biases. So that's our goal. So we did some of this already. We're talking about the gradient descent method. We described it like this. Where we're going to change theta using calculating a gradient first, and then updating theta with the gradient, and we also allow for an extra parameter here, alpha, which we call the learning rate, which we can adjust to control the performance of the algorithm. And we described the loss function or the error function, and we gave it a form. We chose a particular form, the cross entropy form, but we could use other ones. And we're now working on this step here, where we've been sort of playing around with or thinking about this. That is taking the gradient of the loss function with respect to theta. But we really haven't done that yet. We've just been sort of playing around so far, looking at other gradients, which kind of practice for actually doing this. So we haven't done this yet. So let me remind you of something called the chain rule in calculus, and we need it in the case where we're doing multivariable calculus. In other words, basically here we have a function. We have a function z, which is a function of two variables, x and y. So not the single variable case, but it's a function of two variables. On the other hand, each of those variables, x, for example, is a function of some other variable, t, and y is also a function of t. So we're asking, so we see z is a function of x and y, but these x and y are actually functions of t. So it makes sense, or we could ask, how does z change? How does z change when we change t? Even though z is not directly a function of t, but of course it is, because it's a function of x and y are both functions of t. So it does make sense to ask about the change in the change in z with respect to t. And the chain rule tells us the answer to that in this way. It says that we can calculate it as the change in z with respect to x, and here we have to have partial, because z is not just a function of x, it's a function of x and y. So if we talk about the derivative with respect to x, we have to use partial derivative. So we use that. And then times the derivative of x with respect to t. Now this also makes sense. That is, x is a function of t, so we can ask for what's the derivative of x with respect to t. And this is not a partial derivative because x is just a function of t. It's not a function of other variables in this situation. And then we get the same thing on this for this piece here. So this is called the chain rule, and it kind of looks like this. So we have z as a function of x and y, but x and y are both a function of t. I'm just saying that's the relationship. So they give you some examples here, but anyway, just we want to remember this form here.